Hello everyone. We are going to enter into part 2 of Unit 5. So far we've been talking about bonding, and now for the rest of our unit we're going to talk about how to name compounds and write formulas. So today I will just be talking about how to name ionic compounds. So we're going to begin by learning how to name binary ionic compounds. So first you need to know that the word bi means two, and ionic means that you have a cation and an anion, so a positive and a negative ion bonded together. And in this case, that is going to be a metal and a non-metal. So here are some examples: iron 3 bromide, sodium chloride, and gold 1 phosphide. Now, I just read you the names of these compounds, and I'm going to explain how you are going to name them. So the first thing you need to do is write the name of the metal and the nonmetal. Then you're going to change the ending of the nonmetal to "ide. And then, since some of these metals are going to be transition metals, we don't know their charges. If you remember, I only taught you the charges for metals in groups 1, 2, and 3, and we completely skipped the middle section of the periodic table. And that's because those metals can have more than one charge. So you have to indicate in the name what charge that metal has. And this system of naming with Roman numerals is called the stock system. So this is just explaining transition metals can have more than one oxidation number, or more than one charge. So when writing the name, you must include a Roman numeral to indicate the charge. And in order to determine what the charge is, you have to look at the charge of the anion. So I'm going to flip over to my document camera for a second, and I'm going to explain all of that a little bit further. So I first want to review with you the first 10 Roman numerals, because I'm sure it's been a while since you've had to use these. So the Roman numeral for 1 is just I. The Roman numeral for 2 is II. 3 is III. 4 is IV. 5 is just V. 6 is VI. 7 is VII. 8 is VIII. 9 is IX. And 10 is just X. Okay. So iron, we're going to name this compound now. Fe is iron. And iron is a transition metal. So that means it can have multiple charges. And you have to include the charge or the Roman numeral when you name this compound. So to figure out what iron's charge would be, I need to look at the anion. I need to look at bromine. Bromine is in group 7, so that means it has a -1 charge. But you have 3 bromines. So that would be like saying I have 3 bromines with a -1 charge. So if I wanted to know what is the total charge of all of those bromines, I'd add each of them up. Or if you're looking at this, you'd multiply 3 times 1. So the overall charge is -3. Well, for ionic compounds, they have to be electrically neutral. That means if one side is -3, then the other side has to be +3. So that means iron has a +3 charge. So I'm going to write the Roman numeral 3 next to iron. And then when you name bromine, for nonmetals you have to change the ending to "ide." So the name of this would be iron 3 bromide. All right, we're going to name the second one. You're probably very familiar with this compound. Na is sodium. Now, since sodium is a group 1 metal, we learned that group 1 metals always have a +1 charge. We don't need to put a Roman numeral in the name because the charge is always +1. So we can just go on to our nonmetal. This is chlorine. But we're going to change the ending to "ide," sodium chloride. And moving on to our last one, Au is gold. Gold is one of your it is one of your transition metals. So that means it has multiple charges. So we will have to include a Roman numeral. So once again, to figure out what gold's Roman numeral is, let's look at the charge of phosphide. Phosphide is in group 5, so that means it has a -3 charge. And remember, we said ionic compounds have to be neutral, so that means gold has to be +3. But this time, we have 3 golds. So that means that each gold, all 3 of your golds, together, their charge equals +3. So the charge of each one individually must be +1. So again, what we just did is we just divided 3 by 3, and we got +1. And when you write your Roman numeral, you want to give the charge of the individual gold ion, not the charge of the entire, of all 3 of them. So we're going to put our Roman numeral 1 for gold. And then since phosphorus is our non-metal, we're going to change the ending to phosphide. So that's how you name those first 3 examples from our PowerPoint. So going back to our PowerPoint, skip ahead. So if you need further explanation, I've included that on the slides. For this slide, FeBr3, here bromide's charge is -3 since there are 3 bromine atoms, so iron must be +3. And then for that third example, phosphide's charge is -3, so gold must have a +3 charge. Since there are 3 gold atoms, the charge of 1 gold is +1. Gold 1 phosphide. All right, so that's how you name binary ionic compounds. Now we're going to learn how to name ternary ionic compounds. So ternary means 3. And again, it's still ionic, so we're still talking about cations and anions, but this time you're going to have a polyatomic ion in your formula. And here are the examples we'll be looking at. So in your packet, you have a list of polyatomic ions. Now this is not a complete list, this is just the more common ones that you're going to see in the work we'll be doing. So something you need to know about polyatomic ions, the word poly means many, atomic means atom, and ion just means that it has a charge. Now, how is this different from what we've seen up until this point? So far, we have only looked at monatomic ions. So that's 1 atom with a charge. For example, sodium ion looks like this. But for your list of polyatomic ions, you'll notice that you don't have single atoms by themselves. You have a group of atoms, and this group of atoms is covalently bonded together, meaning they are sharing electrons, and they all share a charge. Now this list, I'm not going to make you memorize these. You will be able to use this sheet on your quizzes and tests. I have laminated copies of these for when we return to school, but you do need to be familiar with them so you can learn to easily recognize them. So let's look at some examples from the slides. This first example, you might recognize this. Na is sodium. So we're just going to name it like we normally would. Sodium is a group 1 metal, meaning it's always +1 and we don't need a Roman numeral. So now we see 2 atoms bonded together, phosphorus and oxygen, PO4. That is actually on your polyatomic ion sheet. So if you look down here, PO4 is phosphate. So that's all we're going to do is write the name phosphate. And that's it, sodium phosphate. All right, for our second example, you probably recognize Cu is copper, so we're going to name our metal. Now we are going to need a Roman numeral for copper, so I'm going to leave a little place here and we'll come back to it in a minute. But copper is a transition metal, meaning it can have multiple charges, and that's why we need to include a Roman numeral. So NO3, if you look on your chart, NO3 is nitrate. So we're going to write nitrate to name that polyatomic ion. Now you might have also noticed that nitrate has a -1 charge. Now keep in mind that this entire thing, NO3 as a whole, has a -1 charge. So that means that copper must be +1. So the Roman numeral for copper is Roman numeral 1. And then lastly, we have magnesium. Magnesium is a group 2 metal, meaning it's always +2. We don't need a Roman numeral for that. And then SO4 is on your polyatomic ion sheet. That is sulfate. So this is the name, magnesium sulfate, and that is actually the formula and the official chemical name of Epsom salts. So now we're going to flip back over to our slides, pick up where we left off. So this is just your rules for naming. Name the metal cation, name the polyatomic ion, add a Roman numeral if you need one. Now, if you looked at your polyatomic ion sheet thoroughly, you might have noticed that there is one positive polyatomic ion on that list, and that is ammonium, NH4. Ammonium is made up of nonmetals, and so if you were to have ammonium as a part of a formula, you would see 4 nonmetals bonded together. That just means that it contains 2 polyatomic ions. So NH4 is ammonium, and SO4 is sulfate. So the name of that would be ammonium sulfate.